All right, let's jump right in. We're going to try and get our heads around a huge question today. How does an AI actually understand us? I mean, we talk to it, it talks back, and it feels like magic. But what's really going on under the hood is, for the most part, a very, very clever guessing game. Let's pull back the curtain.
Everything, and I mean everything, boils down to a simple sentence, like this one. The bank was steep. Now your brain, my brain, we see that and we instantly picture a scene, right? But for an AI, this little sentence is a real head-scratcher.
I mean, what is a bank? Is it the place you go to deposit a check? Or is it the grassy edge of a river? This ambiguity, this simple little puzzle, is the exact challenge that every language AI has to solve. And how it solves it tells us everything we need to know.
And that brings us to how things work right now, which is basically the AI guessing game. Because today's AI doesn't truly know the answer. It just plays the odds, making an educated guess based on all the text it's ever seen.
So this is kind of the AI's default setting. In the billions of sentences it's read, the word bank has shown up in a money context way, way more often than a river context. So before it even looks at the other words, it's already got a strong bias. It's 99.5% sure we're talking about finance. So how does it adjust that initial guess? Well, this is where it gets really fascinating. The magic of modern AI, the very engine that makes it seem so smart, is actually a secret that's been hiding in plain sight for more than 2.5 centuries. Okay, whoa, that looks complicated, right? This is the famous attention mechanism that powers all the big models like GPT. But look, forget the scary math for a second. The key isn't what the symbols are, but what the formula is actually doing. And that part is way more familiar than you'd think. Because what it's doing is this: Bayes' theorem, first written down way back in 1763. At its heart, both of these formulas are just a formal way of doing something very human, updating what you believe when you get new information. So let's put it all together. When an AI reads, "The bank was steep," it's not thinking like a person. It's just running a Bayesian update. It starts with its 99.5% belief in financial bank. Then it sees the word steep. That's the new evidence. And the attention mechanism just crunches the numbers to see how much that new word should shift its initial odds, eventually swinging the probability over to riverbank. It's 260-year-old math just running at an absolutely insane speed. But that raises a huge question, doesn't it? Why does AI have to guess in the first place? Why can't it just know? Well, the reason is baked into its very design, what we can call the architecture of approximation. So this is basically what's inside the AI's head. It's called a dense embedding matrix. Think of it as a giant, incredibly messy spreadsheet. Every word gets a row, but its so-called meaning is just a long list of numbers. It's a complete black box. Those columns, those numbers, they have no inherent meaning on their own. And here's the fatal flaw in that design. The system tries to cram the entire, infinite richness of human language into a fixed-sized box, and that leads to this problem called concept superposition. It's like trying to store your tools, your clothes, and your groceries all in the same kitchen drawer. Everything gets tangled up.
And just how tangled are we talking? Well, this number says it all. In today's biggest AIs, on average, every single one of those dimensions is a confused mashup of about 163 completely unrelated concepts. The system is just fundamentally incapable of storing one single, clear idea in one place. And that fundamental messiness leads directly to this formula. Now don't worry about the letters. The most important symbol on this screen is that little squiggly equal sign. It means approximately equal to. The output, y, can only ever be an approximation. The entire system is built from the ground up to guess. Okay, so that's the problem. It's a big one. But what if we could scrap that design and start over? What if we could build an architecture of knowing? The key to this new approach is a radical idea called the token. Instead of that vague, messy list of numbers, a token is a unique, unforgeable cryptographic hash. Think of it as a semantic fingerprint. So bank, the financial institution, gets one unique token, and bank, the riverside, gets a completely different, unique token. The ambiguity is just gone, eliminated by design. And just look at the difference this makes. This is the new architecture. It's not a black box, it's a glass box. Every single row and column is labeled with a specific token, representing one and only one concept.
There's no overlap, no entanglement, no mess. And you see all that empty space? That's the real magic. The fact that this matrix is 99.75% empty isn't a bug, it's the entire point. It means the system isn't wasting unbelievable amounts of energy computing noise. It's hyper-efficient.
So what does this actually mean in the real world? What happens when you make the leap from a system that guesses to a system that knows? Well, the impact is frankly staggering. First, let's talk about speed. Because the system no longer has to do a massive search and run probability calculations, it can just retrieve the concept directly using its unique token. The speed up is astronomical, up to 20,000 times faster. It's the difference between wandering through a library looking for a quote versus knowing the exact page, paragraph, and line number instantly.
And all of that wasted computation that's now gone, it has a massive real-world impact. This deterministic approach is up to 400 times more energy efficient. That dramatically slashes both the financial and the environmental cost of running AI at scale.
Now, this kind of change doesn't just upgrade the old system, it makes huge parts of it totally obsolete. Entire multi-billion-dollar industries that were created just to patch the flaws of the old guessing-based architecture, they just become unnecessary. The market for model training, for trying to explain the black box, for bolting on external knowledge bases, a combined $88 billion, poof.
So this is the world we're in now. A world of approximation. A world where AI gives us an incredibly sophisticated, incredibly useful guess, but it's still just a guess.
And this is the new world we're moving into. A world where the answer, y, simply equals the data m. No more approximations, no more probability, no more guessing. This is the formula for actual comprehension. And that leaves us with a pretty profound question to think about. When our AI systems can help make critical decisions in medicine, in finance, in our legal systems, with verifiable certainty instead of just statistical probability, the possibilities are just limitless. So if our machines can finally stop guessing and start knowing, what kind of world should we build with them?